far is about half of this page. We've been through linear equations, we've been through exponential functions. So now we're going to get into polynomials, which means two or more terms. Poly means more than one, nomial means terms. So that just means more than one term. We'll get to the review part after. Now some of this we're going to jump over because we already collected like terms on 3 different lessons this year. We don't need to do it a 4th time. So we will jump straight into multiplying polynomials, which has to do with your exponent rules that you learned before the break. So first of all, let's just quickly glance at the linear functions. Whenever the highest exponent is an imaginary 1, that's a linear function no matter what. When the exponent is the variable, whether it's an x or a t, if it's a variable, then that is an exponential function. Now, whenever you see a 2 exponent, it's going to be a quadratic function. This is what we're going to be mainly working on for the next few weeks, the quadratic section. Now, cubic is when there's a 3 exponent, but for the purposes of this class, we will not be working with cubic. So we're going to stop at quadratic, which means after we get through quadratic, we're going to do statistics, and the rest of the year is review for the EOC. Any questions so far? All right, so first things first. To be a different term, the two expressions have to be separated by a plus or a minus. Notice how there's a minus here, plus, and a minus there. Those are the separators of the terms. So how many terms do you have here? 4 terms. Very good. 4 terms. Everybody with me? How about if I say 6x, y, z, f? How many terms do I have there? 1 term. Exactly. So that's the main thing I want you to remember from this page. If there's no plus or minus separating things, then it's all one thing, 1 term. Clear? Now, polynomial just means more than 1. So anytime you see 2 terms or more, you can call it a polynomial. But a polynomial with 1 term, with 2 terms, has a special name. A polynomial with 3 terms has a special name. So that's the next thing that we'll review. The names of the terms. So mono, bi, and tri are the prefixes to all these words. All of them end with what? Nomial. Nomial means term. So what do you think mono means? Looking at the example. 1 term. So mono means 1. So when you see 1 term, we call it a monomial. 2 terms, we call binomial. And 3 terms, we call trinomial. Anything above 3, we can just straight up call it a polynomial, even though both of these are also polynomials, but there's no special name for anything past a 3-term expression. Because for Algebra 1, you're going to work with linear, exponential, and then quadratic. Quadratic reaches up to the 3 terms. So that's just what's included in this course. So far, so good. Now, next, we're going to review the degree section of this polynomial. By the way, your polynomial worksheet, first page is a word search, just to get used to the terminology. Second page is a crossword puzzle to get used to the terminology. And the last page is the multiplying polynomials page we're doing. So I just want to kind of warm you up. I know you just came from break, so I'll warm you up to real work. Tomorrow we'll start with the regular worksheets from the beginning rather than activities. It is already on Google Classroom, so you just do it on Google Classroom. You can either print it and send me a picture of it done in pencil, or you can use like an annotate tool like Ibis Paint or anything like that to do it with your stylus or your finger. So Over here, degree of a monomial. Monomial means one term. So when you have something like this that's one term, all you're looking for is the highest exponent. What's the highest exponent you see? A 6. That means the degree is 6. Now, don't get tricked on example 2. What's the degree of example 2? Not 4, because that's all one term. So, think again. 7. 7 is a degree, because that whole term has how many total exponents? A 4 and a 3 is 7. Everybody with me so far? Now, that was the degree of a monomial when it's one term. A degree of a polynomial, same concept, but you're just looking for the term with the biggest exponent. So, yeah, I usually do. Yeah. Let me find it. Hold on. You're not bothering. Yeah, they're all here. You won't have them sifted. Oh, it's for your kids. So I'll pick the cleanest ones then. Chilling. Those have been there forever. You're welcome. All right. So look at example 1 here. What's the highest exponent? A 7. So the degree is 7. It is this simple. You're just looking for the biggest exponent, and that's what you call a degree. So don't get tricked on example 2, just like I told you, don't get tricked on example 2 on the purple examples. Over here, what is the biggest exponent you see? 6. 6 is correct. Now watch why that's not a 4, because that's a 4 and a 1, which together give you 5. This is a 3 and a 3, which together give you 6. That's the biggest one. So the degree is 6. This is the definition part. The worksheet itself is just going to be the multiplying stuff, which you've done before in this class, so it won't be brand new. Because when we do exponents, we learn multiplication of polynomials. All right, so far so good? Questions? This is this is just a degree. You don't have to copy all of it. Just understand that we're looking for the highest exponent when they say degree. If it's one term, it's that one. If it's a polynomial, look for the biggest one. So far so good? All right, let's go to the next page here. Now, we're not going to do this page. We're just going to kind of refresh your memory on it. Collecting like terms, we've done so many times in this class. We're not going to do it a fourth time. Now, just to remind you, to be a like term, it has to have the same variable and the same exponent. So 2x squared is a like term with what other term? 1x squared. So when you put it together, 2 plus 1 gives you 3x squared. Notice what I did. I added the numbers, but the variable and exponent stayed the same. So with addition and subtraction, exponents don't change. We're not working on that. You should know this already. Now we're going to get to multiplication. So these are the first two examples. I'm going to do one, let you do the next few on your own. So this is what the worksheet's really going to be about. So over here, 5a square has to be distributed to every term in the parentheses. How many terms do we have in the parentheses? 3 terms, so we should get 3 results. You with me? So when we multiply the numbers, but the exponents don't get multiplied. What's the rule with the exponents and multiplication? Add them. Very good. So 5 times -4, -20, and a to the 4th power, because you're going to add the 2 and the 2 on the variables. Now distribute to the next term. 5a squared times positive 2a gives you positive 10a to the 3rd power. Why is it a 3? Because there's an imaginary 1 on the a exponent. Don't forget it, because that has to be added with the other exponent. Last term, 5a squared times -7. Do you see an a on the -7? That means there's no exponent to add. So you multiply the numbers and get -35, but the exponent is going to stay as a squared because there was no other exponent to add with it. Now, see how those exponents don't match? These are not like terms, so you can't do anything else. That is your answer. All right, so now let's do the green example. On the green example, what's going to be distributed to the first parentheses? 2p. What's going to be distributed to the second parentheses? -5. Once you do that, you're going to get a whole bunch of results. Then check for like terms, combine them, and you're done. So 2p times -4p to the 2nd power is -8p to the 3rd power. Add the exponents. Don't forget there's an imaginary 1 exponent on the p that we're distributing. Now distribute 2p times positive 5p. It's positive 10p squared. Notice we got 2 results. How come we got 2 results? Because there's 2 terms in the parentheses. Now we're going to get 2 results from the next distribution. -5 times 2p squared gives you -10p squared. And -5 times 20 is -100. Now what terms are like terms? 10p squared and -10p squared. So if you combine those, they equal 0. When something equals 0, it disappears. So all you need to do is bring down the first and the last term, and you're done. That's your answer. So on the next page, you're going to have 2 examples to do on your own, but one of them is tricky. So let me explain something to you. If you're multiplying 3ab squared times 4a5b5, what are my results going to be? Three ab2 times 4 a to the 5th b to the 5th. What's my results here? 12 is the correct coefficient, which is a number touching the variable. Now, what is the exponent on the a? 6. What? A6 and B what? B7. Why is it 6? Because the imaginary 1 on the A and the 5 on the A get added to give you 6. This one's 2 and 5, which added give you 7. So that's the main thing. When you go to the next page, there's going to be 2 examples. One of them is going to have different variables. So don't add, for example, the exponents from the t with the exponents from the y. T's with t's, y's with y's. Okay? In this case, it's only going to be t's. The y's are just going to come down next to the term. So go ahead and try these next 2 OYO on your own, and I'll review them. I'll give you a couple. All right, let's review these 2 examples. So -6d to the 3rd is what's going to get distributed. How many terms are in the parentheses? 4. So you should get 4 results. So negative 6d to the third times 3d to the fourth is negative 18d to the seventh. Now we got negative 6d to the third times negative 2d to the third. That's positive 12d to the sixth. Negative 6d to the third times negative d is positive 6d to the fourth. And the last one, negative 6d to the third times 9. Do you see a d on the 9? That means that d to the third is going to stay as d to the third because there's nothing to add it with. So multiply the numbers to get negative 54 and bring down your d to the third power. Now none of those exponents are the same, so you're done. This whole row is your answer. Any questions on that one? All right, so let's distribute on the orange question now. On the orange question, it's 15t that's getting distributed. So numbers get multiplied, exponents get added. 15 times 10 is 150. But the t has a 1 exponent on it. You add it with the 1 that's on the t over there. It gives you t6, y3. Notice what I did. I just put the t with a 6 because I added 5 and the 1. Yes? You're both, you're both asking the same exact question, you and Leo, Andres. So yes, it's T6Y3 is the same as Y3T6. I will mark it wrong, but if you have an answer choice, A, B, C, D answer choices, it'll always be the way I wrote it, because the correct way to write it is biggest exponent first. You with me? So I wrote it the correct way, but like I said, IXL won't mark it wrong, I won't mark it wrong. Probably EOC won't mark it wrong, but these questions are usually multiple choice questions, which means you have to pick it out of the lineup. So let's keep on distributing. We distributed the term to the first one. There's only one more term to distribute it to. 15t times 5y squared t. That gives you positive 75 t squared y squared. Now these exponents do not match, so you're done. This is your answer. What? It doesn't matter. It doesn't matter. Like I said, in this case, they're both two exponents, so which one you put first doesn't matter, but I always put it in the same order that I did on the other one to see if they're like terms. Because imagine you have like T3, D2, and on the other side, you have the same thing but inverted. You might not notice that they're like terms. So if you write it in the same order, you can catch it if it's a like term. Okay? All right. Now we get to something you're definitely used to. You've seen this before, so hopefully you remember. This is very, very important for the EOC. So look over here. Normally there's, what we've done so far, one number, one term being distributed to a parentheses. In this case, it's going to be a binomial times a binomial, so there's two terms that have to get distributed. So first we're going to distribute the 2x to both of those numbers. What's 2x times 1x? 2x to the second power. 2x to the second power because you add the imaginary 1 exponents that those x's have. Now you distribute to the 5. 2x times 5, positive 10x. Everybody see that? I got two results because I distributed to two numbers. Now, what's the next term that needs to be distributed? The 3. Very good. So positive 3 times x, positive 3x, positive 3 times 5, positive 15. Now, on the two binomials, when you multiply them, your like terms will always be in the middle. So let's look in the middle and combine these two like terms. What's 10x plus 3x? Positive 13x. And now the first and the last number just come down. And that is your answer. No, 2 times 1 is 2. You add exponents. You multiply numbers. I did. That's why it's a 2. A 1 and a 1 equals 2. It's okay. The result was 2. That's probably what was confusing you. This is the perfect time to make mistakes like that while I'm teaching it. So we can fix it in class instead of during the EOC. So mistakes right now are wonderful. Now let's do the orange example. 3x needs to be distributed to both terms on the other parentheses. So 3x times x, 3x to the second power. Very good, 3x squared. 3x times negative 2, negative 6x. Now we distribute the next one. Positive 4 times x, 4x, and 4 times negative 2. Negative 8. Thank you, Andres. Now combine the like terms in the middle. Don't forget the signs that you see belong to those numbers. That's not 6 plus 4. That's negative 6x plus 4x. So that equals negative 2x. And the first and last number, as always, just come down. This you've done before because we did the activity and we've done a bunch of these. Now the last example before I let you try a couple on your own is the purple one over here. X times x, x to the second power, x squared. X times negative 3, negative 3x. Now we distribute the 10 to the two numbers. 10 times x, 10x, and 10 times negative 3, negative 30. Now where are the like terms going to be? In the middle. So if you put together negative 3x plus 10x, it equals positive 7x. Everybody with me? Now what happens to the first and last term? It just comes down. X squared and the minus 30. Now finish copying that. I'm going to put two problems here for you. You can already start it on your own, and then I'll review them. On your own. These are on your own. I'm going to put 3 for you guys here. Go ahead, try those 3 examples on your own. Moment of truth. Let's see if we get this right, or if you got it right. On the first one, the middle term is going to disappear because you're going to get the same exact number, but one's going to be plus, one's going to be minus. So I'm going to do it, but that tells you can skip those middle 2 steps when you're distributing, when you have the same numbers on both sides, but different signs. So watch, 4x times 4x, 16x to the second power. Now here's where we're going to get two terms that repeat and cancel each other out. 4x times negative 3, negative 12x. Now we're going to distribute the positive 3 times the 4x, which gives me positive 12x. And the last distribution gives you negative 9 because it's 3 times negative 3. Now when we combine the like terms in the middle, they disappear. They equal 0, which means they're gone. So the answer is just what you're bringing down. Don't forget the minus. So this is 16x squared minus 9. Now, on the red question, notice how both parentheses are the same, but the signs are not different. So how is that one going to be different than the orange one we just did? It's not going to cancel. Very good. So 2x times 2x, 4x to the second power. Very good. 2x times positive 3, positive 6x. Now we distribute the 3 to this side. So 3 times 2x, again positive 6x, and 3 times 3 is positive 9. Now you can combine the like terms in the middle. 6x plus 6x gives you 12x, and bring down your plus 9 at the end and the 4x squared from the beginning. That middle one is what we call a perfect square trinomial. You have the exact same on both sides without anything canceling. That's called a perfect square trinomial. So let's label it perfect. At least write perfect on there so you know it's a perfect square trinomial. That's the same thing. You expanded 2x plus 3 squared to be 2x plus 3 times 2x plus 3. No, it doesn't matter. It doesn't matter. As long as one's, yeah, it doesn't matter. So now here, the middle one is a perfect square trinomial because the numbers are exactly the same on both sides. But when you have same numbers on both sides but different signs, we call that a DOS. Difference of what? No, you guys have heard me say this in this class before. Difference of squares. Difference of squares. This whole thing deals with squares, square roots. Quadratic functions have a 2 exponent. What do you call a 2 exponent? A square. So that shows you this whole thing deals with squares. That's because you added exponents when they shouldn't be added. You see how it's 2x times the 3? Do you see an x on the 3? That's why there's no x to add with the first x. So just erase those 2's and then you'll see them. That's a good question. Yeah, Berta? No, you have to split it up because then you're not going to get two results in the middle. If you just put that 2 exponent on these two numbers, you're missing half of the work. You're going to be missing the middle term. So no, in this case, you cannot just put the 2 on both numbers. You have to expand it to 2 parentheses and then distribute like we've been doing. That's a good question also. All right, now we go to the pink question. 2x times 3x, 6x to the second power. 2x times negative 4, negative 8x. Now we can distribute the positive 1. Positive 1 times 3x, positive 3x, and positive 1 times negative 4, negative 4. Now combine the like terms in the middle, and it equals negative 5x in the middle, because negative 8 plus 3 is negative 5. And you bring down your first and your last term. Done. Any questions so far? Pretty clear? Copy it down and we'll get to the last page. So while you're working out the pink question, I'll explain what we just did on the other one in case you missed it. We distributed the 2x to all three terms on this side and got these three results. Then we distributed the 11 to all three of these terms and got the next three results. Combine the like terms in the middle. These two are like terms. They equal positive 5x squared when you combine them. 4x minus 33x gave us the negative 29x there. First and last term just come down. All right, let's review it. So 6x times 2x squared, 12x to the third power. 6x times negative 3x, negative 18x squared. And 6x times negative 5 is negative 30x. Now we have to distribute the positive 5 to the three terms as well. Positive 5 times 10x squared, positive 10x squared. Positive 5 times negative 3x, negative 15x. And the last one, 5 times negative 5, negative 25. Now there's two sets of like terms in the middle. Start with the two exponent. Negative 18x squared and positive 10x squared. When you put them together, gives you negative 8x squared. Now we also have like terms over here. Negative 30x, negative 15x, which gives you negative 45x. Now the first and the last term just come down. So the 12x to the third comes down at the beginning, and the negative 25 comes down at the end. That is your answer. Any questions? Pretty simple. What's the area of this pool? Let's see if you really understand. What's the area of this pool? No. How do you find the area? Multiplying what? Both sides. The length times the width. How many terms do you have for your width? Two terms. So don't multiply the 3x only to the 2x. It has to go to both terms. So distribute in your head. What do you get? 6x what? To the second power, because when you multiply 3x times 2x, 6x squared. Plus what? Plus 15x. Simple? This is all that's on the worksheet. What we did right now, examples. So you guys that are at home, go ahead and go to Google Classroom. Pull up this document. It's 3 sheets because the first one is a word search. Second one is a crossword. Third one is the actual worksheet. So use the words from the word search for the crossword puzzle. They're almost identical. If you have trouble with one, just ask me. I should be able to give you a hint. Okay?